Welcome to Lecture Online, and here we're going to do the same exact problem as we did in the first example, but now we're going to do it with what we would call maybe a different method, because some texts, they rearrange the way they calculate Markov's chains, and they rearrange the matrices. So here you can see this is the way we showed it the first time. This is what we call the future method or the predicted method. This is a probability matrix, and there's the current matrix, meaning this is the current state, this will be the future state. Over here we have the future state, here we have the current state, and there have the probability matrix. And if you look carefully, the probability matrix here is transposed compared to the probability matrix there. So we take this matrix right here and we transpose it like that. So instead of 0.8, 0.2, 0.1, we have it 0.8, 0.2, 0.1. We have it vertically instead of horizontally. The result is you get the exact same answer. But you have to be a little bit careful. You have to understand which methodology they're using in your particular case. Are they doing it like this, or are they doing it like this? My personal preference is like this. It seems to be more intuitive for me to look at it and understand it, but this is a perfectly good method used by many institutions and many textbooks, so we have to know how to do both. Again, notice the current state is the number of customers in each location as a percentage of the whole, or as a fraction of the whole. So 40% go to A, 24% go to B, and 36% go to C, which is indicated with our current state matrix right here. This is going to be the future matrix. What will it be a week later when people have moved to different stores? Notice that 80% will stay in store A for the following week, 70% will stay in store B, and 60% will stay in store C. At the same time, from A, 10% will go to B, and 10% will go to C. From store B, 20% will go to A, and 10% will go to B, and from store C, 10% will go to A, and 30% will go to B. So what will be the number of customers in the store the following week? We'll go ahead and work out the matrix. And so notice that if you want to fill in this matrix, this is what we call the probability matrix. It is from to. So from A to A, from A to B, and from A to C. So here you can say from A to A is 80%, which is what we have over here. From A to B is 10%, so from A to B is 10%, that's right here. And from A to C is 10%, so from A to C is 10%. Now, from B to A, so from B to A is 20%, does that match? From B to A, 20% right here. From B to B is 70%, we know that. And from B to C is 10%, so from B going to C is 10%. Now, from C to A, 10%. So from C going to A, that's 10%. From C to B is 30%, that's correct. And from C to C is 60%. So again, it looks exactly the same. It's just that the matrix is set up a little bit differently. So now let's go ahead and work it out. So for the first cell right here, this is equal to 0.4 times 0.8. So we multiply this times this to get the first cell. So 0.4 times 0.8. So let me go ahead and do that. That would be 0.4 times 0.8 plus 0.4 times 0.2, 0.4 times 0.2 plus, and then we have 0.24, sorry, 0.24, because I have to take the next element, multiply times this, and plus 0.36 multiply times 0.1, and that will be the first element of this matrix. See how that makes it a little bit more difficult to write on a piece of paper. I would have to have a really long line right here, which makes it less useful. So then the next element right here, let's put it on here. So that would be 0.4 times 0.1, so 0.4 times 0.1 plus 0.24 times 0.7 plus 0.36 times 0.3. So that would be the next element. So that's the first element. This is the next element. And now we need the third element. And the third element would be 0.4 multiplied times 0.1 plus 0.24 multiplied times 0.1 plus 0.36 multiplied times 0.6. And that would be the third element. So this then would become, so this times this, now we need a calculator, of course, to do that. So this still the same. 0.4 times 0.8 plus 0.24 times 0.2 plus 0.36 times 0.1, 0.36 times 0.1 equals, and I get 0.040, 0.404. There we go. That's our first element. Second element, that's this multiplication right here, so 0.4 times 0.1 plus 0.24 times 0.7 plus 0.36 times 0.3 equals, and that would be 0.316. And on the third element, 0.4 times 0.1 plus 0.24 times 0.1 plus 0.36 times 0.6 equals, and it would be 0.280. So that would be the future state or the current state. Actually, not the current state, but the future state. So this is the current state. That's the next state. So either we call it the next state or the future state. Let's just write that down. So that's the next state or future state, if you want to look at it. And this would be the current state. And this would be the probability matrix. Notice we get the exact same result. We multiply this times this, we get A, B, and C in the future state or the next state, and we get exact same. Now, notice the difference. If we add the numbers vertically right here, they all add up to 1. So this plus this plus this, that's 1. This plus this plus this, that's 1. This plus this plus this, that's 1. So if we add them in this direction, we get 1, we get 1, we get 1. On this matrix right here, if we add them to the right, if we add them in this direction, notice that this is 0.1, oh, not 0.1, but that's 1. We add this is 1, and this is 1. So when we add the numbers together, the cells together to the right, from left to right, we get 1. Here, if we add the cells from bottom to top, we get 1. And for the state matrix, notice when we add these all together, we get 1. And here, if we add these all together in this direction, we get 1 as well. So that still holds true. It's just that here they all add up 1 in this direction, there they all add up 1 from left to right. Methodology is a little bit different. It's whatever you prefer to do, whatever seems to make more sense, but I find it easier to work with these numbers on a piece of paper than to work with those numbers right there on a piece of paper. So I tend to gravitate to this method. So most of my examples are going to be like this. I'll do a few like that so you can see what the difference is. So now you've seen the simple method of the Markov chains just for one single transaction or one single calculation. Of course, you will do this over and over and over again to see over time where the customers will end up. And we can use that for all kinds of examples, and you'll see lots of different examples how we can apply this in business and science and so forth in predicting what will happen in the future based upon the current state and the probability of change. And that's what we call Markov chains.